Alright, so getting started with simulation software. Now we are going to be using two different pieces of software. The Allen Bradley / Rockwell Connected Components Workbench Standard Edition. We are also going to be using Factory I/O. Now, we're going to start with the Connected Components Workbench. This is software from Allen Bradley that is for their Micro 800 series PLCs. Now, the big benefit of this is it has a simulator built in for the 850, I believe it is. So we have an actual simulation that we can run. We can program code, we can download it to the PLC, we can turn bits on and off, all other fun stuff. So that's the benefit of this software. Now, I'm going to be having a file up for you to download that is compressed file for this that already has a bunch of tags created and things like that for you, so that way you don't have to go through and make all the tags again. So to open that, you're just going to go File at the top of the screen. You should already have the software installed, I should mention that. If you don't, please go ahead and follow the other assignment to get this software installed. To open that file, you're going to do File, then you'll say Import Project. You may have to go find your file wherever it is downloaded to. In my case, I'm already in the Import-Export folder, which where mine happens to be. I'm going to go with the copy file. You should go with the actual template. And I'll just say Open, and it's going to go ahead and basically unpack that folder. And there is a folder for each project that includes a bunch of files in it. So this is just basically with just like Siemens, where you have the pack and unpack, I believe what it was. Same idea, we're just compressing everything. Alright. Now, quick little tour here. So on the left we have our project organizer, we have programs, which we don't have any of, we have global variables, which we do have a whole bunch of. We'll go through those in a minute. We've got function blocks and data types. So let's go ahead into the global variables folder. Alright. This is just like your project variables in RSLogix 5000. So this is giving you all of your tags that you have. Now, by default, we are using currently an Micro 850. All right, and in this global variables folder, it starts with IOEMDOOO through DO19. Those are all of our actual digital outputs on the microcontroller. So if we would look right here, all the green screw terminals in the bottom of this would be our digital outputs. All the screw terminals in the top would be our digital inputs. If we go back to our variables, you notice we then have DI for digital inputs. Alright, so that's kind of nice. However, that is not how Factory I/O is going to talk to us. It's not going to actually be affecting the actual inputs and outputs. It's just going to be affecting other tags. So in our case, that is the Boolean in 0 through 15 and Boolean out 0 through 15. We also have float outs, we have float ins, we have ins, and we have int outs. Alright, it may be worth your time, it probably is, I should say, to come through here and create aliases for these things, which I'll show you how you know what the alias should be in a minute. But anyway, that's where all of those are. They need to be in the global variables from what I can tell. Alright. Now, if we go to programs, we want to create a program for this. We can right click on it, we'll say add, and notice we do have three options. We have structured text, ladder diagram, and function block diagram. Alright. What we have been using in class so far is the ladder diagram. That's what we're going to continue with right now. We might get back to one of those other two or both of them later this semester, but right now we're in the ladder diagram. You give it a minute. On the left, you notice now we have our program 1 and we have local variables. If we go into local variables, you'll see it is empty. Alright. If we go to program 1, you'll see something that looks hopefully similar to what we used in RSLogix 5000. It's not exactly the same. We do have those same different organizers at the top of the screen, which give you the different sections. So you have favorites, run branch, bit, program control, math, compare, move, copy. There's conversion, so any to byte, any to date. So if we need to convert from one data type to another, which actually may be very handy in this class. We have timers and counters. That's one's kind of way out there. We have some advanced math stuff. All right. So all these are going to be a little bit different than what we use in RSLogix 5000 or in Siemens TIA Portal. So that is something to be aware of. All right. If we want to go ahead, we have under bits or favorites, you have your normally open, your normally closed. So you can drag those. Notice how a little plus sign appears, not the little green dot anymore. I like the plus sign a little bit better. All right. Once you drop one in, it'll ask you what you want. Notice that right now you're like, hey, I'm missing all my data types. Well, if you go to Global Variables tab on the left, then you'll have all those options again. So we could say Boolean in 0, just say OK. All right, now if you're like, okay, let's have an output on it, you can click an output, it throws on the right. Double click on it, we can say, okay, it's going to be bool out 0. All right, we've got our little code written. All right, now we need to start the simulator. All right, that is going to be at the top of the screen under the Tools section. All right, and it says Micro 800 Simulator. Control-Alt-T is also a shortcut for starting that. So we can go ahead and click on that. Another window is going to pop up. Now, this has my IP address of the desktop that I'm currently on. All right, so that's 192.168.0.152. You could also use the software loopback interface of 127.0.0.1. Doesn't really matter which one you're using if both sets of software, your factory I/O and your connected components workbench, are on the same computer. If they're on different computers, you need to use your Ethernet connection or Wi-Fi connection. Don't use the software loopback. That won't work. So make sure you're using that Ethernet connection. This might be actually a benefit if you have this installed on 2 different computers. That way you can have the simulation for the factory open on one screen and see what's happening and be able to interact with buttons and things while having the program on the other screen on another computer. Now that only works if you have 2 computers. If you have 2 monitors, then that's a great option as well. That's how I do it. I have 2 different monitors traditionally. That's how I'm running it. I'll also show you split screen is another great option. However, that also really only works if you have a bigger monitor. If you have a small monitor, split screen is not really the best option. I think I have like a 27 or 29-inch monitor at home, and doing a split screen on that is fine, but I wouldn't want to go much smaller than that. Anyway, once you have the simulator open, you have to make sure you turn the power on to it. So we can go ahead and hit the power on button. Notice we've got our power light turns on. Actually, let's go ahead and turn this back off for a second. Can I not do that? I guess I can't do that. All right, let me just exit that and start it back up again. Now, you will notice on my simulator, because I was playing with this before, I have some modules in here. All right, you do not need to have any of the modules in here. Let me just go ahead and get rid of them now. Really, what you should have is this. Whatever you have here should match whatever you have up here. Now, again, because we're doing this all simulated between factory I/O and connected components workbench, we're not actually using the real inputs or outputs, so we don't have to have the analog cards and things like that installed. If you're doing this in the lab, we would have to have those analog cards so we could get the analog values. So that is something that you might want to be thinking about. However, for our purposes, we want all of our modules here to match what we have up there, which is none up here, none up there. So now we should start the system. Now that the system is started, we can go ahead and hit the download button. Now you will notice up here it already says the IP address. Alright, so I can do the set up the connection path just like we did. If you don't have an IP address, or yours probably actually will have my connection path, let me go ahead and clear that. Once I hit the download button, it's going to be like, where's your PLC located? Just like Allen Bradley software or Siemens software does. And you should recognize this window from the Allen Bradley software because this is still RS links. Alright, so we're going to go into the AB EthIP-1 Ethernet, and then you can see that we have our Micro 850. We don't have to click the plus button and keep drilling down till we find the backplane or the processor like we did with the RS Logix 5000. Just selecting the PLC here is enough, and you can go ahead and just hit OK. Now, at bottom we do have our output, so it's telling when we hit the download button, it says build 1 successful, 0 failed, 0 up to date, 0 skipped, so we're good to go there. Download confirmation. We want to download or download with project values. Now the project values are the values for the tags that are saved in the project file itself, not the ones that are on the PLC. So if you're uploading to a PLC that's been online for a while, it might have counter values that are at 50 or 100 or whatever. If you hit the download button, those counter values are not going to change. Where if you hit download with project values, those counter values will change to whatever you had saved in your program. So that becomes a very important topic. If you had outputs that were on when you saved your program, when you re-upload, those outputs might default to being on. So that is something that you do want to worry about. So in our case, it doesn't matter which one we're using right now. We'll just hit the download button. All right, down at the bottom is telling us what's going on. So we're build started. It was downloading a second ago. Download one successful. Now it's saying, do you want to go to remote run mode? Or obviously the answer should be yes. If you say no to that, that's fine. Up here, right at the center of the screen, we have run and program option. All right, it's still catching up. So it's going, hey, this is what you have written on the PLC now. So let me go back to here. So if I go ahead and click this over to run mode, now we can say yes. Now it does give you a warning that you can only run in run mode in the simulator for 10 minutes at a time. It does seem like after that 10 minutes elapse, you can just click the program and then click back to run and you'll be fine to go again. We shouldn't be running it much that is more than 10 minutes at a time. Alright, now if we come back up here, so you can see our PLC is in run mode now. Alright, otherwise we really don't need this screen. Alright, now if we do go back to our program, you can see here our Boolean in. If I toggle that with Control T, you'll see our Boolean out becomes true. If I toggle it again, you'll see that our bool out goes back to 0. If I go to my variables and I go to bool in and I actually check that box, you'll see that our bool out 0 box becomes checked. Alright, so this is like in RS Logics where it's telling you 1 or 0. So check boxes are saying, hey, it's on or it's off. Checked is on, not checked is off. Alright, so just something to be aware of. And there we go. Now, also, did you notice that delay? I clicked this box. It should be instantaneous that bool out turns on. It's not. There's a little bit of a delay there. I'm convinced that's because of the simulator. Now, I haven't tried to see if we can make the simulator run any faster or anything like that. However, that is one of our problems that we do have with this. Is it seems like the simulator is running a bit on the slow side, which we're going to come back to in a minute. All right. Now, we've got our simulator open. We do have a simple program on there, which is fine. All right. Now we need to go to Factory I/O. All right. Now, Factory I/O, pretty awesome software. All right. It allows you to build simulated factories with conveyor belts and actuators and sensors and things like that, and allows us to program that using an actual PLC. So if I got my Siemens 1200 PLC that I have at home out, I could hook that up here and I could hook it up to this Factory I/O, and I could program the Siemens PLC and actually have it being what's controlling the simulation in Factory I, which is really neat. All right. The getting started document is actually probably something that is worth going through. Same with the parts. All right, let's go ahead and just click through the parts. It's going to bring up a website. Same with the other one. All right. But notice we do have different options. We have heavy load, we have light load, and they have like conveyor belts for both of those. We've got different sensors. We have operator related stuff, the buttons and stop buttons and selectors and displays and cabinets. We have different stations. You've got walkways, you've got warning lights, you have emitters and removals. Those are important. Emitter creates an item in that location on the conveyor belt ideally, and the remover takes the item off the conveyor belt. So that way you don't have just a pile of boxes just piling up on the floor. So something to be aware of. Anyway, for now we're just going to kind of go the quick and dirty route here, and we're going to go to the scenes, and we're going to go to, where is it? Level control. All right. Now, level control here is, as we can see, a tank that will have fluid in it. All right. Now, at the top here, at the very top of the screen, starting at the far right, we have the palette window. So if you wanted to actually add more items to the simulation, we could. All right. So if you're like, hey, you know what? We need to have a palette in this simulation. Boom. You can put a palette in. Now notice that palette is floating in the air right now. If I hit play, it's going to fall to the floor, which is actually really, really neat. All right. So the first 9x9 grid is for the palette. Overall, we're not going to be using that much until later when I'm going to have you guys create your own simulations. All right. To the left of that are two that you will be using. We have actuator tags and sensor tags. Now, if I scroll in, we'll go over how to. Zoom, no. Alright, anyway. At the top here you can see we have the level meter and we have a fill valve, and it says that with just straight up text. Alright. If I click on those, if I click on the sensor one, you'll notice the tag goes away for sensor, and I click on the actuator one, you notice the actuator tags will go away. So this is labeling what is what. It also allows you to click on those manually and say, oh, fill. And if I drag that, notice it says forced. Once I, oh, gotta be in play mode. Once I go in play mode, you'll see the actual fill valve will move and it'll start filling the tank with water. If I drag it back to 0, it will stop. I like how even the water bounces up and down a little bit. Notice the level meter is reading something because I'm clicked on it. Again, I can force that by clicking on it and dragging it, and my PLC will see some funkiness going on. To release the forces, you click on it, it says relieved. Now, on outputs, if you click on that little, what I'm going to call a normally closed sensor, it will say failures. So you can say, oh, inject an on failure, inject an off failure, or no failure. All right. Same with the level meter. We can say, level meter is injecting an on failure. Now, if you have just a normal push button, which if we come down here to our start panel, we can click on the start button. This actually injecting an on failure, and then this actually says injecting an off failure. So, same idea. All right. Alright, so continuing left, we have used to select a part or point. So if you double click in space, it will put that little white dot there. Alright. I don't know how helpful that is. I mean, it's nice for moving around. You can just click. Alright. To navigate around, if you hold your right finger in, that will allow you to pan around that white dot that shows up in the center of your screen. Alright, so that is your right mouse button. If you push your scroll wheel in, if you have a scroll wheel that clicks, or a middle click, that will allow you to drag around the screen. Personally, I find double clicking and then right mousing is probably the quickest way, and then the zoom in and out is the scroll wheel, so you can do that. That is probably how I overall navigate, is just zoom in, zoom out, and then double click. Alright. Notice we can even change the set point dial. I love this software. It's really neat. Alright. We continue left. We have select a part to follow. So if you actually click on a box, it will follow it down the conveyor line, which is pretty neat. You can go to a walk around point. So it acts like you're, I forget how tall of a human, and I think you actually walk into things. So like if I try to walk through this tank, I can't do it right now. Alright. So kind of interesting. Can I climb the ladder? That'd be really neat. No, can't climb the ladder. Alright. The next option is the fly camera. So you, again, can like zoom around. WASD also walks you around the room or flies you around. You can also use the arrow pad. We got the next one. That was one we started in, where you can double click on a point and it kind of focuses you there, so you can swing around it, look at things from all different angles, including under the floor. Next, we have time scale. Now, this one is very important. All right. It seems, I believe, if I remember correctly, at least on my computer, I think it's because of how slow the simulator is to responding to the actual code running, that it likes to run at half scale. Don't run it at full time. Don't run it at 1. I haven't even tried anything above that. If you run it at full time, you'll notice like a box might completely pass a proximity sensor or something before the software triggers and goes, oh, there was a box there. I should stop the conveyor belt. So half speed or lower. So I've been running at half speed when I've been playing with the simulations. You can reset the simulation, pause it, stop it, those types of things. All right. Now, the last, probably most important aspect in configuration that you have to set is if we go to the edit screen, file and do drivers. All right. Now, because this is trying to interface with an actual PLC, we need to set up what PLC we're using. All right. So in this case, we are using the Allen Bradley Micro 800. All right. Now, if we go to the top right-hand corner, mine automatically connected because I already set this up once, but you need to set yours up first. So you need to go to that configuration, all right, for the Allen Bradley Micro 800. It's just having auto connect selected. And then here's where you have to put your IP address of the Micro 800 simulator. So if you go to the Micro 800 simulator screen, right here at the top it says that it's 192.168.0.152. So notice that's what I have here as my host. So those have to match. I left the I/O points by default, so that would be my suggestion for you. But you might end up needing to change those at some point. Let me go ahead and go back to disable auto connect for a second so I can disconnect. All right. So notice you can change these. You can be like, oh, I want start to be boolean 1, not boolean 0. So you can actually change those things if you want. So once you hit connect, you'll probably actually watch or see if you watch all the tags right here in the center. If we hit connect, you'll see they all had that little red exclamation mark going like, hey, these tags don't exist on the PLC yet. And then it was like, oh, wait, yes, they do. So if you have red exclamation marks in here, it's because it was trying to find these tags on the PLC global variables, and it didn't find them. So rather important to just kind of keep your eye out for that. So now, in theory, we're good. Again, I like to have auto connect enabled, so I'm going to go ahead and click that. And we can go ahead back. Now, one other setting that I suggest you guys make before we move on is if we go to File and we go to Options, under Video, all right, under Display Mode, instead of having full screen, which is what it is by default, I highly suggest Window Mode, all right? And the reason I suggest Window Mode is because that allows us to dock our factory I/O on one side of our screen and our PLC on the other. That way we can see both happening at the same time. Now, if we go ahead and zoom in on the start button here. Alright, and we go ahead and play. Let me make sure those are all released. And if I come back over here to my code, and I zoom out just a hair so you guys can see the entire code, which is just boolean 0 equals bool out 1. So if I go back to my drivers, which is, wrong screen, F4, if I look at boolean 0, that is my start button, so that would be the alias you might want to create for your start for boolean 0, and my bool out 0 is the start light. So F4 will take you back. So if I click the start button in the software, we should see that happen. Oh, I'm still paused. That's why. Here we go. If I click, we should see over there on the left it went red. Now it's back to blue. All right. I don't know why we don't see the light turning on. Let's go ahead and click Start Light. Is our program not running anymore? Yep, we're not in run mode. Look at that. Alright, so let's go ahead. It's been more than 10 minutes. Put it back into run mode. Right now, if I click this, notice that the light turns on. And once I let go, the light turns off. That's pretty close to real time. It's not quite. Alright, now let's go ahead and just jump this up to 1. Notice it happens just as fast at 1 speed as it does in half speed. Alright, so like if you were to go to 4 times, it's not like that light's turning on any quicker when I click that button. Alright, so it's just because the simulator, I believe, is running kind of slow. So I like the half speed. It'll keep you from missing boxes and things like that. So that allows you to connect connected components Workbench to factory I/O through the simulator. So that way you can actually run your code and see it happen on the in factory I/O. Now, let's do one more quick example of this. So we're going to write a really quick and basic code here. Alright, so we are disconnected. We're back in our code. Let me go ahead and delete both of these. Let me go with my global variables for a minute. Alright, actually, let's go ahead and dock this to the left again. Hit F4. Alright, so I care about my flow meter in and my flow out. So float in, float out. Oh yeah, actually I care about my fill valve and my. I want the start button and the fill valve. There we go. So I care about boolean 0. So let me go ahead and give that the alias to start, and let me give the fill valve float out 0. Fill valve. just like, actually you'll see this in a second, but just like in RSLogix 5000, it does not like your names of your tags to have spaces. So if I go ahead and create a tag, we'll call it full speed. If I put a space in it and I hit, I can't hit tab to move, I hit enter, it gives me a little like red exclamation mark, like, and notice it says, if I hover over that, there we go. Oh, it goes away really quick. Basically, can't use spaces is what it's trying to say. So once I get rid of that space, we're good. We're going to make this a real data type. I'm going to give it an initial value of 10, and I'm going to call it no speed. And again, we're going to make that a real data type, an initial value of 0. All right, so now if we go back to our program, I can say start button, and then we're going to do a move. And I'm going to go full speed, and we're going to move that to fill. And I'm going to say when I press the start button, alright, give me another one of those, give me another move command. This time we're going to say when we're not pressing the start button. Oh, we got to go here. Here we go, alias start. And I'm going to move no speed to, now let's see, can I drag this? Nope, can't drag it. That's kind of sad. Alright, so now if we go back to my processor, the Micro 850, we're going to hit the download button. We can go ahead and get out of this. Download with project values. We're building, we're thinking, it's uploading, you know, it takes a little bit. Even the simulation, it takes a little bit. Alright, and I hit the don't, I don't know. If you want to get rid of this warning, hit the don't show me again, but, you know, to each their own. So now whenever I press the start button, oh, gotta be in run mode. Whenever I press the start button and hold it, we should be seeing alright, not working. Wonderful time to troubleshoot. Oh, I know. This should be float out, not float in. Alright, so gotta disconnect. Float out 0. I named the wrong tag. That is my bad. One of those things that you guys do, I do, it's a wonderful time. You got to make sure you name your tags right, or name your, give aliases to the right things. So fill valve is an output, not an input. So I was actually trying to tell the level meter that, hey, there's value there, but there was not. Alright. So now let's try this again. I click fill. Oh, we're paused. Let's unpause it. Click fill. There we go, the fill valve at the top of the screen moved, and we're filling the tank with water. And when I let go, alright, the fill valve closes. So, there's my little 30-minute tutorial on how to use the Connected Components Workbench and Factory I/O together with a simulated environment, and how we're going to be using it this semester. Go ahead, guys, play around with this, go through the different scenes. There's a lot of fun ones here. They have one without the sensors on it. They have just a little counting based one from A to B set points. They have a whole automated warehouse, which I haven't looked at yet. Elevators, which we might be doing, those types of things. So, you know, it'll be fun. We're going to have a lot of hard tasks for you guys to do, but it's going to be a good time. There's going to be a lot of troubleshooting because I'm going to send you guys scenes and things. And we're also probably going to be having each of you make a scene that does a specific thing, and we're going to see how your guys, you know, each of your scenes compares to the others and those types of stuff. So, all right, guys, I'll be posting your assignments. We are going to continue with the assignment that we were at before we left, which was having this fill up and to a specific set point, say a level of 3, and I'm gonna just randomly set the discharge valve to something. I'm gonna be like, okay, that discharge valve is gonna be set to 2.8, and you should be opening that fill valve more and more and more until we get above the set point value, and then you should start closing it until we kind of get that up and down, up and down, up and down, and until you hopefully get to a nice, like, okay, the valve is just on or just changing ever so slightly. All right, you will need to use counters for that, and because you don't want to run this every time, remember. Some of you guys had that problem in class where you were doing this and it was running at every loop of the code, which was happening so stinking quickly that it was changing your numbers astronomically. So, and I'm not sure if this counter at this point in time works like Allen Bradley or Siemens. I would assume it would work like Allen Bradley, but they've got this labeled as Q as the output. Well, let me put code after that. Ooh, you can rearrange these. That's kind of nice. Alright, well, let me put an output. We'll put the output after it, so who knows. And you might have to, let's go ahead. It's called, oh, we already have it, CTU1. Look right there. Once you put a counter in, it creates a local variable for you for it. That's really nice. And you can't, oh man, go back. We double click on that instance right there, it tells you, so yeah, kind of nice. Alright, gentlemen, start playing around with this. I'll have an assignment posted for you hopefully soon, and we'll go from there.